Thank you. The last section of the chapter. We have a 1 o'clock out Friday. So my whole plan of what I was planning to do is I was going to do the review on Friday. Since we have a 1 o'clock out, I'm going to move it to Monday. Okay, so Thursday, tomorrow, you guys will have an opportunity to either work on your review or work on your poster. Friday, we're going to do a class activity to just reinforce some of the parabola things that we're learning, because we'll have a shortened class period. And then Monday is when the review and the poster are due. Monday in class, then I'll go through the review, and then Tuesday will be our test. We'll move on to Chapter 6 on Wednesday. Okay? Questions on that? From this point forward, I just love this class. I love polynomials and rational functions, and it's my favorite part of algebra, and we're getting ready to start it. So exciting. I know. I really am. I embrace it. It's always been true. Okay. So we're going to go to Section 512, which really is nothing new, but it's going to be something where we can learn how to find some of these points that we've been looking for on the calculator, and also how to model real-life applications with quadratics. Okay, so the first thing I want everybody to do is type this function, and some of you may be in there already. Type this function into the graphing calculator. And to do that, you're going to go to the y equals button on the calculator. Make sure if there's something in there and it matches negative 16x squared plus 18x plus 5, you don't have to do anything. But if you don't have that in your calculator, then you want to type this in for the y equals. Clear out the screen, okay, and then type in negative 16x squared. And everybody know where the x button is? Okay, plus 18x plus 5. Once that's done, hit graph. Okay, and if your graph is not in your window, one thing you can always try is to go to the zoom button and then go down to number 6, which is standard, and click on that, and it'll give you a 10 by 10 window. Okay, and what I always like to do when I'm trying to find the vertex or the zeros or the y-intercepts, I want to make sure that everything I need to find is kind of in my window zoomed pretty well. And so when you look at this graph, everybody has their graph in the window?
No, mine keeps saying error.
Okay, look on Lacey's then.
Really
look on Lacey's then. Okay, go to zoom. No, go to window. Okay, and maybe we'll just put in like x min is negative 3, x max positive 3, y min is fine where it's at, and y max make 15. So x min negative 3, x max positive 3, y max 15. And by doing that, I'm just kind of shrinking the window so that my graph enlarges a little bit in my picture window. Does that make sense? So when you hit graph again, hopefully your graph now is a little...
Every time I say negative 3, it goes to...
You've got to use the bottom negative, not the minus sign.
Okay.
The bottom negative. You see on the... Okay. You want me to go through the dimensions of the window again? Okay. X min is negative 3, x max positive 3, y max 15. And then hit graph. And now your graph should kind of be centered in that window. And you can see the vertex and you can see the zeros pretty easily. Okay? So to find the vertex, notice that because this has a negative sign as the leading coefficient, that the graph is going downward, which is what we expect. So the vertex actually represents a maximum value. And when you're trying to find the maximum values, you're always looking for the y-coordinate of the vertex. So if the question said, what's the maximum, and in fact this one does, if this function represents maybe something being shot off a cliff or something being projected from a cannon and then falling back to the ground, and they want to know the maximum height, To do that, you're going to find the vertex and then look at the y coordinate, and that's going to tell you the maximum height because height is measured in the y direction. Okay, so to do that, you're going to go to second trace, scroll down to maximum because we want the maximum, not the minimum. And now it's got a blinking, when you hit enter, it's got a blinking cursor, right? Make sure that blinking cursor is somewhere left of the maximum on your curve. Somewhere left on the maximum. Go down to maximum. And this is not an exact replication of your graph, but if I'm looking for this point, I'm going to go to second trace, scroll down to maximum, and my cursor, I want flashing somewhere to the left of that vertex. Hit enter when you've got your cursor somewhere to the left. And now you're going to use your arrows and arrow over until your cursor's passed over the vertex and is somewhere on the right side.
Wait, what?
Okay, so go to second trace,
We already did
scroll
that.
down to maximum.
Yeah, we got the cursor. We just
Okay, the first, it says left side or something like that.
Left bound.
Left bound, question mark. Left bound means I want the left, somewhere on the left side of my maximum. Okay, and once you've just put your cursor somewhere left of your maximum, hit enter. Now it says right bound. So use your arrow button, arrow over, so your cursor is somewhere to the right of your maximum. Then hit enter. And then it says guess, question mark. You want me to guess? Yes, you do. So hit enter again.
That was error.
we got
Down, enter. Arrow over, so it's past the vertex. And then enter. Enter again. There it is.
What do you want the dimensions to be?
Wow.
Huh?
Because I got my calculator. What did you want the
-3 to 3 on x min and x max, and 15 for the y max. Okay, so you got like -0.5625, comma 10.0 something or other.
5625007.
Yeah. I just,
Because isn't it always different?
for you guys, it should all be the same because it's the same function. But that, you didn't?
Not exactly the numbers like you said, no.
0.56250, yep, and 10.0625. Yep, same thing. Everybody got that for your vertex. So that means the maximum for this graph happens to be at 10.0625.
Wait. The maximum.
Is the y coordinate of the vertex. Okay, so let's do second calc maximum. Left bound, it has to be left of the vertex.
Yeah.
Right bound is right of the vertex.
Oh, double
There it
enter
is.
after that. I didn't do that.
Okay. All right, so now we found the vertex of this function. And the vertex then can tell us the maximum value. Now we want to find the zeros. The zeros, again, represent if I were to solve this function using the quadratic formula, factoring, completing the square, I would get my zeros. Well, if you put your function in and you graph it, there's another way to find your zeros without having to do all of that. Okay, so this might be helpful on the test if you want to check your answers. Okay, because I'm still going to expect work on completing the square and quadratic formula. But once you get your two answers, you could actually go into the graphing calculator and do this, and you can actually check your work. Okay, so on the calculator, you're going to hit second trace and see the selection of zeros, or 0. Okay, going to go down and select that. And I'm looking for these two. So I'm going to have to do this twice. I'm going to do it once for this point and once for that point. So when it says left bound, this is kind of important when you're dealing with the graphing calculator. To trace this graph, I go from left to right. Left to right as I trace the graph. Okay? So if I want left bound of this 0, it's going to be below the 0. So make sure your cursor is below the 0. And if I want right bound, then it's above the 0. Then you hit enter again when it says guess, and it'll tell you what that first 0 is
Above the 0 for right?
for the right bound.
0 is x equals 1.3555,361.
Okay. Did everybody else get the same number?
I got,
I got negative 0.23.
yeah, I got that.
Yeah, I got that one, so that's why I got
Ooh. I got 1.
Okay, so make sure. Go again. Second trace. Go down to 0. Where it says left bound, make sure your cursor is flashing down here. And if it's not, use your arrows to get there. Hit enter, and when it says right bound, make sure your cursor is flashing up here.
Okay, well now I got 1.3, 55361.
Wait, on the other side though, do we do it?
On the other side.
Oh, I put it
The same
below.
thing
I
that
put
you
it
just
below
got
on the other
right
side.
there.
Never mind. Yeah, I know what I
Second
meant.
trace.
Wait, what'd you just
Times
tell me?
0.
Put it.
That
So I'm just doing the left 0 right now.
was right.
I'm doing this 0 on your graph, whatever it is. I'm doing this 0. Okay? I do second trace and I go down to 0. When it says left bound, I make sure my cursor's down here. And then when it says right bound, I arrow over until my cursor's above. Then I hit,
Left side though.
yes, on this side of the graph.
That's below,
Just
right?
below the graph, above the below the 0, above the 0 that I'm looking for.
Still got negative.
Below the 0, above the 0. Right here.
I legitimately don't know.
Okay,
Okay.
I got the same
So I
answer
do
got.
second trace.
What'd you do?
0. I want left, so that's
No.
below. I go above, hit enter. That's the 0.
Is there
It should be negative. It should be negative 0.2305361. Okay, to find the second 0, this is where it gets a little confusing, so just follow the logic here. To find the second 0, again, we're going left to right. So if I want left bound of this point, it's going to be above. And right bound of this point will be below, opposite of what it was over here.
So left bound is going to be above.
Right bound's below. And you do the same thing and you find your second 0.
That's the first 0. Okay. Okay.
Everybody get it? Okay, so if you end up using the quadratic formula to solve this, and you get a root, then just on the calculator, figure out if it's 3 plus the square root of 5, then just take 3 plus the square root of 5, get your decimal, and compare it to the 0 the calculator tells you it is. And then you can check your answer and make sure that you did it right. Okay? We good there? Now, to find the y-intercept, this was not talked about in the text, but it was talked about in the video, which is one of the answers to one of the textbook check questions. To find the y-intercept, what is the value for the y-intercept of x? 0. So on the calculator, go to second trace. Second move. Second trace. And where it says value, number 1, just hit enter. And it asks you to put in a value for x. So just put in 0. And it'll tell you what the value of y is at that number.
5.
5.
So that is your y-intercept.
Boom. We're that good.
Which, what's that? Is it plus 5? At the end of the function? Yeah. Yeah. So if they'd given it, well, yeah, you're
Oh my
right.
god, she's gotten to
If you look at your function, right, it was negative 16x squared plus 18x plus 5. Plus 5 is your y-intercept, right? But if you wanted to find it on the graphing calculator, that's how you do it. Good there? Okay, I want to talk about couple other things. One other thing you're going to see at the very last problem on WebWork, they want you to do a quadratic regression. We did linear regression when we were learning about lines. Okay, what it involved was just entering your list of numbers and then hitting linear regression, and it tells you what the coefficients of x and the constant are. Okay, same thing is true with the quadratic regression. So I'm going to give you a list of numbers, and I'll refresh your memory on how to enter these. So what they're doing, what they're telling you is, let's say they did an experiment, and they got these x and y values in their experiment. And they know that this particular experiment should follow a parabola pathway. So they know it could be represented by a quadratic. It's not a straight line. So they want to figure out what the formula is for their data that closely matches their data. So then they could use that to predict future things of data that they don't even have measured. Does that make sense? So what we're going to do, you're going to go to Stat on your calculator, Stat, and Edit, and you should get L1, L2, L3, something like that at the top.
Stat plot?
Nope, just Stat,
Oh, right there.
and then Edit, and you have a list there. If you have numbers in your list and your numbers match 0, 4, 7, 12, 17 on the X, you don't need to do anything. If they don't, I'll read those slower. Who does not have those numbers in their list?
0, 4, 7, 12, 17.
Mm-hmm. For X, for L1. Okay, so if you don't have those numbers and you've got something else in your list, remember all you do is you go to the top of the column, hit clear, enter, and it'll clear out your list. You can start over. So the numbers for X are 0, this would be L1, 4, 7, 12, 17.
What is O2?
Okay, L2 is going to be the Y. And L2 then for Y is 7, 9, 10, 8, and 3. Those are your L1 and L2. 7, 9, 10, 8, 3. Okay, so all we're going to do now is go back to Stat, do a second mode, which clears your screen. Second mode, okay. Go back to Stat, and now instead of Edit, go to Calc. And then scroll down until you see quadratic regression. Second mode clears your screen. Then go to Stat, the same button you did to put your list in. STAT, the button that says Stat. It's right below the delete button, I think. Did you find it?
Okay, there it is. Oh, wow. I am
Okay.
blind.
Then go to Calc, and then go down to Quad Regression, or Quad Reg. Hit Enter, and then I think you hit Enter again.
I forgot to put O2 in. What?
For L2, 7, 9, 10, 8, 3. Okay, so now at the top it says like ax squared plus bx plus c, and then it gives you a, b, and c. Does everybody have that?
No. D and E.
Whoa. Whoa.
I have AX squared.
Mine just popped up 3 dots.
So let me see your
AX
Stat,
to the fourth plus BX
edit.
to the third plus dot plus.
Okay, and then we go second
You know,
mode,
Corey, I don't want to hear it.
clear, Stat, Calc, and a Quad Regression. L1, L2.
0, 4, 7, 12, 17.
Oh, that's what, the numbers were wrong.
Okay, so it gives you ax squared plus bx plus c, which is a quadratic equation in standard form, and then it tells you what a, b, and c are. So all you have to do is replace a with the number, and b with the number, and c with the number, and you've got your quadratic that's represented by that data.
Will you help me with mine? Stat, edit.
Okay, so L1, L2. Now go second mode,
Yep.
Stat, Calc, go down to Quad,
Quadrant.
Enter, go down, Enter. No, just, yeah, and then calculate. Go to, into Enter. L1 and L2. Edit.
Chromebooks.
3. I don't think you have anything here, but let's just clear it. What is that?
Literally.
So it's definitely L1 and L2.
Dude, that's amazing.
You want to stand up, and yes, he did.
L1, L2.
When he sat down, he about missed it.
I don't know. It should work. If you do it with, if you get that calculator and a quiz or something, and I have a question, then just get a different one. But this is what it'll come up with when it works.
Okay.
Ax squared plus bx plus c, and then there's a, b, and c, and you just plug them in.
All right.
Okay. All right. So this is just a way to use the graphing calculator to solve some of these problems. Okay. The last thing I want to talk about is an example here. Okay, sometimes they're going to give you just a couple of pieces of information and they want you to come up with what the equation for the quadratic is. Okay? If they give you the vertex and a point, you're going to use the vertex form. This is the general form for the vertex form of a quadratic. A times x minus h squared plus k. If they give you the intercepts, the zeros, the roots, the solutions, you're going to put it in intercept form, which is this. The important thing to note is there's an a in front. Okay? So when you're trying to figure out what the quadratic is that matches the information they give you, this is the process. Okay? In this form, they gave us the vertex. So if I were to write this in this form, what comes next? What is h?
It'd be plus negative.
H is negative 2, so when I put it in here, it's going to be x plus 2. And k is negative 4. Right?
Yeah.
So I'm going to put the vertex into the form. If I were doing it over here, and let's say that I gave you, your zeros were here, you would say it's x minus 3, x minus 2. Right? Everybody see that?
Yes.
Okay. So I'm working on this one, but I just wanted to show you kind of what the similar situation would be in the intercept form. Okay. So now I have this. I have 3 unknowns. I have y, a, and x. But they give me another point, which they will give you. Okay, so this is x, this is y. So I say 8 equals a times 2 plus 2 squared minus 4. Okay, 2 plus 2 is 4. 4 squared is 16. So 8 equals 16a minus 4. I add 4. 12 equals 16a. Divide by 16. A is 3/4. Now, to finish up now, I'm just going to go back up to this problem, and I'm going to replace A with 3/4. And now I've just shown you the quadratic that's represented with the vertex of negative 2, negative 4 that goes through the point 2, 8. It's this quadratic. And I can visualize what this is. Is it going to open up or down? Up. The vertex is actually going to be at negative 2, negative 4. And 3/4 means it's stretched up or compressed. Which one? Which one is it? So we can get a unanimous decision here. Is 3/4 greater than or less than 1?
Plus.
Less than 1. If it's less than 1, it's compressed. If it's greater than 1, it's stretched. Okay? So this is going to be slightly compressed. It's going to be 3/4 of the normal. You know, if my normal quadratic looks like this one is going to be at negative 2, negative 4. And instead of this, it's going to be compressed just a little bit. It's going to be a little wider than the original by a factor of 3/4. Okay, so I can look at this and really, and it's not going to be an exact visualization, but I can really, in my head, visualize what it's going to look like. Okay? All right, so you're going to have problems similar to these on WebWork. You're also going to have a couple that I didn't really do examples for, so when you get to those and you're struggling, then just let me know. Okay, and remember, tomorrow is just going to be a work day, either on your review or on your poster. Friday, we're going to do a class activity. It's going to be shortened periods. And then both the review and the poster are due Monday. Yes?
I'm pretty sure most of us don't have this problem, so can we do it on the board?
Sure.
It's x or f of x equals x squared plus bx. We're finding a, h, and k.
A, H, and K. Okay.
Which would be
Oh, yeah, so the.
It's just.
It's just H and K, right?
Yeah.
So H and K are represented, this is the vertex. To find the x-coordinate of the vertex when it's in standard form, what formula do you use?
Negative B over 2A.
So that's the x-coordinate of the vertex. That's H. So you just type that in. When you type it in, make sure that 2A is in parentheses, otherwise the A pops up to the numerator.
And all the letters have to be capitalized, right?
No, lowercase.
That one's what? That was
H is negative B over 2A. Is it right?
Yeah.
Okay. And now to find K, well, normally, if we know what negative B over 2A is, all we do is we plug it in for X and solve for Y. That's K. When you know the x-coordinate of the vertex, you plug it in for X. Okay? So it's just A times negative B over 2A squared plus B times negative B over 2A plus C. I would prefer that you simplify it if you can, but WebWork will take it exactly the way I've entered, or I've written it. And just make sure that 2A is in parentheses in the denominator. Does that answer your question?
Yeah.
Okay.
So when it's asking for the axis of symmetry,
Symmetry. It's the x-coordinate of the vertex.
so
It's x equals. It's always a line. The axis of symmetry is always a line. You always have to write it as an x equals some number. It's not just a number. It's a line.
use the restroom.
Yes. Any other questions before I stop recording, or I can?
said that x isn't defined in this column.
Okay, hold on a second.